Hello everyone, in this lesson, we will learn about the programming methods and the KAREL programming language used when financial industrial robots communicate well. The Ethernet TCP/IP protocol. First, let's start with the system step for KAREL programming. In previous lessons, we covered how financial industrial robots use Modbus TCP and device NAT to perform I/O communication with PLCs. These I/O communication methods are the most common and straightforward. With the rapid development of industrial automation and intelligent manufacturing, financial robots are playing increasingly important roles in various production lines. However, achieving efficient and real-time data interaction between financial robots and industrial systems remains a significant challenge in the industry. Financial industrial robots typically have Ethernet interface integrated into their system motherboards. Leveraging Ethernet TCP/IP protocol for communication with PLCs can save numerous I/O ports and enable the transmission of more device data types. Beyond PLCs, many other devices can also communicate with financial robots well in Ethernet TCP/IP protocol, such as contactless vision systems. The foundation for this is KAREL programming. Next, please answer this question. When a financial industrial robot communicates with an industrial system well, the Ethernet TCP/IP protocol, which programming language is primarily used? A. Rapid. B. KAREL. C. Labware. And D. Hasten. I will give you 5 seconds to think, and we will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Next, let's explore the structure and application of KAREL programs. First, we'll look at how to add the KAREL language function option. When creating a virtual robotical system in RobotGuide software, you can use default parameters for all options. If you want to use the KAREL language on a real robot, you must add the KAREL R632 software option to the financial robot controller. After adding the option, you also need to set the system variable KAREL env to 1 to enable KAREL functionality. Next, please answer this question. When creating a virtual robotical system in RobotGuide software, which software option must you add to the robot controller to use the KAREL language? A. KAREL R326. B. KAREL R632. C. KAREL Pro. D. KAREL Lite. I will give you 5 seconds to think, and we will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's keep going. Next, we'll learn how to create a KAREL source program. Right-click fields under the robot controller in the left navigation tray. Then select New Field, KAREL Source, point KL from the pop-up menu to create a KAREL source program field. After the creation of new KAREL source program field, the program editing window will open. As shown in figure below, you can read all KAREL program code in this window. By default, newly created KAREL source field are named Untitled and numerical ID and point KL. The rename the source program field, click the Save As button to return the source program field and modify the name of the source program field. When input the field name, the field extension .kl must be saved, such as test.kl. Otherwise, error will occur during programming. Next, please answer this question. What happens to the robot when the UI1 IMSTP emergency stop signal is off? A. The robot accelerates. B. The robot decelerates and continues executing the program. C. The robot stops, accelerates, and applies the brake with the throttle system power turned off. D. The robot enters standby mode. I will give you 5 seconds to think, and we will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. Next, we will cover KAREL program writing. In the KAREL program editing window, write code as shown in the following example. From this example, we can see that the program is divided into 2 parts using program begin and end. All KAREL programs must start with program and end with end, and both are essential. Test is the program name, which you can customize. However, it must be noted that this program name is also the program name loaded into the teach patent. -- indicate line, comments, which add understanding but do not affect program execution, the same as // in C language. Between program and begin, there are customized variables, deceleration, and loading options. For example, the include in the picture functions like include handle.h in C language and import in Python. Next, for variables definition, we must note the following points. 1. Just like in all programming language, keywords cannot be defined. For example, you cannot use integer as a variable name. 2. Customers' variable names can have up to 12 characters. 3. Variables must be defined before use. 4. Different variable types. For example, the type of input well is integer. Next, please answer this question. Which of the following is an involved variable definition in a KAREL program? A. Integer well. B. Input well. C. 1, 2, 3, ABC. D. My variable. I will give you 5 seconds to think, and we will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. The code between begin and end contains executable systems. We got begin as the program's return point, similar to the main function in C language, but you cannot define new variable here. Next, we will learn how to compile a KAREL program. After writing the program, click the Build button to compile the program. If there are no errors, the Build output dialog will display a completion report with translation successful. Meanwhile, the compiled robot executable field test.pc appears under field in the left navigation tree. Here, we can draw a conclusion. Finacle Robot KAREL programs include two field types. One full source program field with the point KL extension, and the other for executable fields with the point PC extensions. All program language calls are written in source program fields. Source program fields cannot be executed by the robot. They can only be executed by the robot after being compiled to generate executable fields. Finally, we are KAREL program testing. On the Teach Pendants control panel, press Select to find the compiled executable text in the program list. If there are many programs, click Tab and select KAREL programs to filter all KAREL language programs. Move the cursor to Test program. Press Enter to select it. Then press Menu and choose User in the pop-up menu. Hold Shift and FWD to execute the program. After execution, the Teach Pendant will display Hello. Enter 0 to say goodbye. Enter 0 and press Enter. The Teach Pendant will show goodbye. Program execution completed. KAREL language program execution complete. Everyone, in this lesson, we will cover the KAREL programming language, including system state, program structure, and writing methods. Through practical examples, you should understand how to write, compile, and run KAREL programs. For more programming examples and advanced communication data process methods, please watch the particle operation videos in this KAREL chapter. That's all for this lesson. See you next time.